All right, so yes. All right, so we've seen these slides before. It can be hard to find a proof, even though it's easy to check. And we talked about having axioms, things that you've assumed on one side, and we kind of brute force forward from that, right? And the other idea is that we have what we're looking for, we know what we need, and we kind of brute force backwards from that. Everybody remember those things? And there's also the idea of having some intuition and jumping in the middle with some statement that you feel is useful, and then it helps you join up, right? So, and then when we were taking up the tests, I just sort of said verbally how I was doing that, and my guess is that went over people's head. So because it's sometimes hard to follow verbally, so I made up slides. So these are all questions that are on the practice tests. So you've seen them before, and we've taken them up before, but let's think about them again. All right, so here's a statement that this function here has a root here and a root here. Now, it doesn't claim it doesn't have more roots, but it is saying that those are roots. So we want to write that down is kind of a math statement. And what it's saying is, well, if x is 2 or x is 5, then the function becomes 0, right? So here's I'm not sure how you would indicate this on a test. Well, I guess if you can't complete it, then it might be nice to have a line that says, hey, this is the stuff that I know we have, and this is the stuff we need. All right. So at the current situation, right, we don't have any assumptions whatsoever, and we need to prove this statement, right? So we're going to have to kind of go backwards. We're going to have to say, well, what the statement we're trying to prove is it implies, and generally the way you prove implies is deduction. So we look up here. Oh, right. So we look on the table. It says under implies and under proving, right? Our goal is to prove this implies. So what are the methods? Well, you can either use deduction or you can build it. All right. And we're not likely to build it because we don't know whether x equals 2 or not, right? We're not going to be able to set these values, and hence we really have to do it by deduction. So then we can just bang in the deduction steps, all right? And what are the deduction steps is, well, I guess I start by saying, hey, we're going to do deduction. I state what our goal is that we're trying to prove. I then put the assumption that the left-hand side is assumed. Down here at the end, I'm going to conclude with the right-hand side. You'll note I haven't said how did I obtain this right-hand side, because I don't know yet. It's something I need. And then, but we do put in this line. This line was proved by concluding the deduction. Right? Everybody buy that? You can just put all that stuff in. And I keep track here of a line which says these are things that I know to be true, and this is something I need to prove is true. And I do find that when I'm marking people's tests sometimes, people will just write down a statement, and I don't know whether they're trying to say, this is what I need to prove, or this is what I have proven. and that makes it hard to mark. All right. So one, if you didn't know how to do anything else, you could write this down as your test paper, and you can get some part marks. You did the deduction part, right? Everybody good? All right, then there's a choice here, right? I can come down here and say, what do I need to prove this, and work backwards, or I can go here and say, well, what can this give me, right? And now you'll note I did, by divine inspiration, know where this line went. You might put the line in the middle because you don't know which way you're going, right? But I put the line in after I'd already proven it. All right, so here, if I have an or, then we can look up in the table and see, well, this is something we know already, right? So we're using the or. How do you use an or? Well, if we knew one of these isn't true, we could select the other one, right? But we don't know that. The other thing we could do is by cases, right? And you all know that you need to know the purple table. I'm not giving it to you. All right, so here by cases, so we say, okay, we got an or, maybe we can do proof by cases. So let's bang out proof by cases. What's our goal? Our goal, well, that's what we need, right? So why don't we write that as our goal, right? Our goal is to prove that by cases. Then we have to say what the cases are. Well, the or tells us what the cases are, right? And we can see, well, if x equals 0, then 2, we plug in the value, we get it. If x equals 5, we plug in the value, so we get it. And then we can say how we get this line, right? We get this line from 3 things. We need the or, we need the case 1, we need the case 2, right? Everybody get that? And since we've linked the 2 together, we have a full proof, right? I don't know if that helped. It helped. All right, good. So then let's do it a few more times, right? So this, you say, well, what is this example? Well, in some of them, I have a meaning for it. And some of them, I just made it up because I knew what kind of proof it would give, right? So here's some statement. Who knows what it says? This is what I have is nothing and I need. And so again, we do proof by deduction. And so we wrote it right in the deduction, right? No thinking. We just copied in the left-hand side, copied out the right-hand side, right? And then this is an and. Well, it's unlikely we're going to use the and hooked together. So what do we do with ands? We separate them, right? So we have the 2 statements, right? And then, well, oh, this is it implies, right? I need it implies. So how do you set implies? Well, either you can build it by getting the values of these 2 pieces, which doesn't seem to be likely. So we need another deduction, right? So we throw in the deduction. Everybody see that? We're just saying, hey, I have to prove this. This is what I need. So I'm going to prove it by deduction, right? And I put in, I assume the left-hand side, and I need to get the right-hand side, right? And now I can say how I got line 10, right? In fact, I'm just thinking making this up right now, but on the need side, the lines that you've already put statements down, I mean, you've already put how you prove them, and somehow you don't need those anymore, right? I mean, you need them, but what's assumed here is you know how you're going to prove them, assuming that we get this line. This line we don't know how we're going to prove it, right? So we need that, and if you get that, then the others we know what we're doing, right? So now we can say, what do we have and what do we need, right? We have this, we have this. Well, I guess we also have this. Now we have these two things, we have three things, and we need to prove alpha, right? So you can kind of look at them and say, how am I going to, oh, we have to prove not alpha. So this kind of says, we could go backwards. We could look at this and say, well, if we got not beta, that would give us not alpha, right? So you can think about that, or we could think, oh, what do we have these two things. What do we do with those two things, right? We have this is an OR. What can you do with ORs? You bring in the table. You just, remember I've given you this table to help you, right? You look up OR, how do I use an OR, right? Well, I could do cases, but let's not do that. I can do selecting OR, right? If I know the OR and I know one of them's not true, right? Then that gives me that the other is true, right? People seeing this, right? It's just without thinking, you just say from the table, from what I have, what the table can give me. And maybe there was some decision making because you had to decide, am I going to do cases or am I going to do selecting, right? But you can kind of think, well, to do selecting, I need to know one of the sides is false. So, okay, is it possible that I'm going to get one of the sides is false? Yeah, there I have it already. So that gives me not beta, right? Everybody good? All right, so now what do I know? Well, I know this implication and I know not beta. So what do I do from there? Well, you can use modus ponens and contrapositive, right? There is this thing of modus tollens, but I never liked it. So I do contrapositive, right? So we're flipping. You flip the direction of the and you negate both sides, right? So that gives us not beta, gives me not alpha from contrapositive from 3. And then how do I get the line I need? How do I link them up? I can just use modus ponens, right? Everybody get that? And then that gives us this proof, right? People see how we're cranking through? So I guess the questions that are going to be on the tests are going to be of this nature, and that if you crank, it should fall out. All right. So this was on a test, I guess. Anyway, some student outside said I had a different proof. I must admit I had a little skepticism because I really crank out a proof, make the question so that it has one sort of proof, but they came up with a different proof, right? What did they do? They saw these two lines and they want to make this line. Any idea what they did? Right? Another way of getting an implies is by transitivity, right? And so here to get transitivity, you need two implies, and we only have one imply, right? But we can take this implies and we can take the contrapositive of it because we need it in the other direction, right? And then we take this or, and remember what we can do with the ors? How do we, right? Here, this says that the or can be turned into an implies, right? I mean, we can sort of do that by how do you prove the implies? Well, you can sort of prove it by deduction. Assume alpha is true, right? Well, if alpha is true, well, then this first bit is false, right? The first of the OR is false. So by selection, we get the beta, right? And hence we know that beta is true, right? So in some ways we can use deduction and selection to prove this, right? The other way we can think about it is, well, if alpha implies beta, well then when is this true? Well, it's true when alpha is true. Oh no, if alpha is false, then if the left-hand side is false, then it's automatically true, right? And if the right-hand side is true, then the implies is automatically true, right? So that's what this is saying if the left-hand side is false or the right side is true, then it's true. Well, then you might say, well, is it true any other times, right? Well, the only case this is ignoring, if you think about the truth table, it's ignoring when alpha is true and beta is false, and it's not true then, right? So anyway, that allows us to turn this OR into an implies, right? Now this implies, right? Oh, so now we got it, but now what do we do? Right? We have this implies and this implies, and we can stick them up by transitivity, right? You can say they link, not gamma gives me not beta, gives me not, so I have not beta, so I get not alpha. Right? Everybody buy that? Yeah. Yeah, probably could do that too. Yeah, I think I didn't follow all of it, but I think one thing I have sympathy for people is I know I can talk easy, and it's harder to follow when people are talking. So if you're not following what I'm saying, holler. Right? Are people getting this? All right. So I have a dear friend who's still one of my best friends. We were graduate students together, and she did her PhD on various proof systems, proving, well, this proof system can prove the pigeonhole principle in small proof, and this one takes a large proof system. And the proof system that takes a large proof system is called resolution. It's a very basic proof system. And one of its most important rules is called the cut rule. And anyway, the rule is this. Suppose you've proven two things already, right? This is the and. You've proven a clause which says that either P is false or R is true, and you've proven that either P is true or Q is true, right? So what do we got here? And here we have a not P, and here we have a P, right? And so you can kind of think, well, either P's not P's. One of these, I was about to say, one of these is true, right? But it's more important than that. One of them is false, right? You can't have both P and not P, so at least one of them is false. And, oops. And whichever one, suppose this one, suppose not P was false, when that would give you R, right? And this one says, well, if P is false, then that would give you Q. And we don't know which one's true, right? So we know that one of them is true. Right? Does that kind of make sense? And so we need to prove it, and we're going to prove it even if you don't understand what it means or have no intuition about why it's true and want to do no thinking whatsoever, right? How can we do brute force? All right, so we want to prove the implies. So we start off with deduction, right? And then, well, we have to prove this or here, and I don't know how to prove the or, so let's come up to this or, all right? How do you think we're going to use that or? Cases, right? We're not likely to eliminate one side or the other side, so we have to do proof by cases. And, oh, I lied to you. That's not an or, is it? See, it's an and, all right? I'm always getting my ands and my ors mixed up. In fact, I just made up a test and I replaced all the ands with an ampersand because, I mean, come on, guys. Maybe I should go globally and change all ands to ampersands. All right, that's an and. So we do separate them, right? And now, all right, so now we do seem to be stuck, right? Truly, I don't know how to brute force it here, right? Because I don't, well, right? I need an or here. I have two ors. What do I do, right? And so, to be fair, in this type, you do need some inspiration, right? But suppose we don't have inspiration, right? So what one could do, but one wouldn't get any marks for it. Well, maybe you get a little marks in this one because it's hard, right? Is you could how many there are three variables, so that's 2 to the 3 is 8 lines, and you could prove it for each line, right? So that's in some ways it's a major proof by cases, right? There are the 8 cases, but instead, can we have fewer cases, right? What might our fewer case, if we want to just branch on one case, what would we do? Yeah. Yeah, exactly. Right. So this handles, right? A proof that handles all the cases all at the same time would be better, right? We have all 8 cases. Can we handle them all at once? We don't know how to do that. All right. So we're going to do this sort of what I call Davis-Putnam proof, because that's what I learned the name of it was, right? We're going to have the cases. We're going to say set one of the variables, right? So you can always sort of, when you're desperate, start doing Davis-Putnam, right? And which variable should we branch on? Well, we could branch on anything, but it doesn't have to be a variable. But here, our intuition was that we branch on a variable, all right? So we're going to do, what are we doing here? I'm just banging in proof by cases, right? So what do we have here? What do we do? We say, what is our goal that we're trying to prove? How did I get that? I got that from that's what we're trying to prove, right? And then I bang in what my cases are. Well, I decided my cases are going to be P is a case and not P is my case, right? And how did I know to do that? Well, I don't know. P appears in 2 different places, right? So if it's kind of, I like to think about it as I have an oracle telling me something, right? She's assuring me that P is true. And then later, she's assuring me that P is false. And so I get to ask her this question. I can ask her, what's the value of P? And I want to ask her something that's going to help me as most as possible. And the reason I think it's going to help me most as possible is because, well, look at P appears in both things. So P seems to be something that would be really useful to me, right? All right, so here are my 2 cases. And then I wrote down here that we've, right, we're going to conclude by cases, but we don't really have this yet. We just still have to get this in both cases, right? All right, so what about, to prove by cases, you need three things, right? You need the two cases, and you need to say what your cases are, all right? So we bang in here that we have by excluded middle, we have that one of them is true, right? And that's going to allow us to do line 6, right? We're going to have line 6 and then some line from this and some line from this, right? Everybody good? Then what do? We say, well, if P is true, again, how do you do ORs? Well, how do you use an OR? Do I have it come out here? Well, one way to use an OR is by cases, and we're kind of doing that already. The other way to do an OR is by selecting OR. If you know one of them is false, then you get the other, right? So here I know P is true, so not P is false, and that gives me R, right? Everybody good? Now what do I do with R? Am I done? Yeah. Building, right? I need R or Q. Well, if I already know R, right, then you should know the building rules, right? I don't memorize the building rules. It's in my soul, right? If I know that R is true, then I'm good. I know the OR is true, right? And so I can bang down the OR, and then I have that case. And then what's the other case is, well, I know P is not true. So again, I do proof by cases. P is not true, so Q might be true. So I can build the OR, and we're done. Right? Everybody good? All right. So this was the exclusive OR, right? She says you can have eggs or porridge. Well, you say to her, I took logic, and or means that I can have both of them. And she says, sure, you can have both of them. You just have to pay for it, right? But she means you can't have both, right? So here's the statement, right? If both are true, then it's right. If they're the same, it's false, and it's true when an odd number of them are true, when one of them is true, right? So one way of banging this out is saying, how do you translate exclusive OR? If you don't have the exclusive OR symbol, and you only have the OR symbol and the AND symbol and the NOT symbol, then how do you build it? And this is actually looks big and cumbersome, but it turns out to be the only way to build it, right? You say, well, if alpha is true and beta is not true, right, then my thing is true. That's one case. Or if alpha, right, you need an or here because you can't have, right, you can't have an and there. It has to be either this is true or this is true. And in the second case, alpha is false and beta is true, right? Everybody see how we translated that? All right. Then we had a simplifying rule, which says, suppose you know alpha is false, right? What can we simplify? Sorry, if you know alpha is true, what can we simplify this to? Can we evaluate this, or do we know whether it's true or false? Yeah, you can simplify it to B is false. Why? Because if B is true, then we get false, and if B is false, you get true, right? So that's why we can simplify it to not be, right? Everybody good with that? Right? All right, so then we can say, right, here's how I made up this sentence, right? Was this on a test? What was on a test this term? It was on a test last term sometime, right? It says if alpha is true, then these two things are equivalent, right? Everybody buy that? All right, so, and then we translate that into that, and then we translate that into that, and then that gives us two statements, right? So in the one, if alpha is true, then this exclusive OR simplifies to not beta. And the other one, if alpha is true, then the not beta builds to right? Everybody buy that these should be true? All right, so then we can just hack them out. All right, so that's what our statement was. How do we, everybody should know how to start, right? And this is where the parsing comes in. You're building a parse tree. You want to see what's the top operation in your parse tree, and it's going to be this implies. And I actually, as I went through and I put in more brackets because when I studied the parse tree thing, I realized that actually my way of parsing was wrong. And so I needed more brackets. And I figured, well, if I need more brackets, then you need more brackets, right? So anyway, there's some nice solid brackets there. So we can do deduction. So we assume the left side and we need to prove the right side, right? And then again, we need to prove deduction. So we assume the left side and we need to prove the right side, right? And then we can say, well, backwards, how can we get from not beta? I don't know how to get back not beta, but how can I use this stuff, right? I have alpha. Oh, well, I don't know how to use this whole big thing, but I do know this looks promising, right? If I knew this was true and I knew alpha was true, then that would give me, right, that this was false, and hence beta would be true. Oh, that's weird. That's weird because I want beta to be false, right? But all right. So what can I also do from this? So here I have an OR, right? How can I use an OR? Yeah, the way you do an OR is by selecting. If we prove one side to be false, right? So here I could have said, hey, I got this OR. Maybe that would have been better. How do I use this OR as I prove one side is false, right? So here I can build, and now this looks like a complicated build. And are you going to memorize this complicated build? I don't know, but it kind of says if alpha is true, then not alpha. Here, my mouse. If alpha is true, up here. If alpha is true, then not alpha is false. And if not alpha is false, then this is an and. So the and has to be false. Yep. It does. Yes. Do you know why it does? Because it is. And why are we back on it? It's because we have a test on Wednesday. And when we covered all these examples were in the practice. But my sense was talking to people were having a hard time with them. And so I made up these extra slides to do the brute force. And my plan was to cover them just before the test. And that's what we're doing, right? And so then you have to say, is this useful? And maybe for some it's useful and some it's not. Absolutely. Absolutely. In fact, I've made up a version of the test. And so I can tell you what's on it. All right. It's really covering all the topics so far. All right. So the one topic we didn't cover too much, but you need to be able to do is translate from English to math. and back again to English, right? Another topic we did is how do you take negations of things, right? The other topic is how do you use the purple table to brute force, all right? So there will be a question like this, all right? And then what do we, then we switch over to Frozen exists, right? And there's proving by the game, and there's proving by the formal proof, right? But we haven't formally done the formal proof, so that's not on the test, right? So but what else is there? Well, the first half of it, we were doing proofs of for all exists, where you know what the model is, right? And you play the game. So that could be on it. And then we did the harder thing where we have an oracle, right? So you're assuming some things that the oracle is telling you, and you have to, and you want to prove something, right? And there's a communication there, right? So those things, that's what's on all of those topics. All right. All right, should we keep doing these examples? Are they useful to people? All right. All right, so how did we get this line? Well, you can imagine it two ways. The one, I could have made it sort of by need. I could have put it down here, I need it. Why do I need it? I need it because if I can get this wrong, then I get that this is right. And that will be useful to me, right? Because there's an or in between. So that's one way I see I need this because of that. But the other way of saying it as well, I got an alpha so I can build it. People understand why you can build this thing, right? If alpha is true, then not alpha is false. And if not alpha is false, then it ANDed with something is false, right? So we have that, and then now we can do selective OR, right, to get the other one, right? And when we have the other one, now it's an AND, so I can separate and get beta. All right, everybody see that? And it does also follow the intuition of why do I believe this? Well, if alpha is true, well, I don't know, there's two cases, and it's not one of the cases, it's the other case, right? All right, so how do we do the other one, right? We do deduction, then again, we have it implies, so we do deduction, right? So we didn't do any thinking here, we just banged down. And now we can say, well, I know alpha and I know not beta. So, well, what can I do? Do you know alpha, not beta? What can I build, right? I can build the AND, right? And then I know the one side of the OR, so I get the whole OR, right? I build the OR. Everybody good? How do many people feel that they can now do one of these? Yeah? All right. So this was our father, right? He says, oh, this is the nice father, right? The nice father says that if you do well at school, I will love you. And he tells you, and if you follow my rules, I'll love you. So there's an and here, and that's nice because you know what the contract is. You know that he will love you, right? So that then translates to, well, then you only have to do one of them, right? If I do one of them, then I have both contracts, and so the contract that I need falls in, right? Everybody good? Yeah. So how do we prove this? We bang in deduction, right? There was an implies here, so I could have banged in deduction there. But what am I doing up here? I'm saying or. So what am I going to do with ors? That's an and. Oh, we got an and. All right, what do we do with the ands? We separate it. Good. Good thing we got somebody on the ball. All right. We separate our ands. Now what are we going to do? Right? Yeah. We're going to do what? Yeah. Yeah. Yeah, you could do cases. How would we get that there are only two cases? Another deduction. The other option is come down here and say, what do we need? And now we do by deduction, right? And now we have, right, it gives us or. All right, so how are we going to get gamma here? I think everybody should eyeball this and say, what are we doing? Yeah? Cases. And what do we need to do for cases? Yeah, we don't have to do anything for cases, right? We have everything we need, right? We can just say, bang, we did it by cases. Right? Does that make sense? Right? Over here, we knew that we did one of them, right? So there's only one case. There are two cases, and in either case, you get it, right? And that, again, that sort of follows the intuition, right? That if there's only two cases, we have both of those cases handled, right? And going the other way, we can think, our ball says that you can handle case, if case A is good, alpha is good, we're good. If beta is good, we're good. Oh, we want to be good. So let's make sure that one of those cases is true, right? All right. We want to go the other direction now, right? We want to prove that these two lines are equivalent. So now we're going to say, suppose that your father says, if you do well at school or you follow my rules, then I'm going to love you, right? So that implies that you have these two separate contracts, right? We're taking this contract and separating it into just two smaller contracts, right? So how do we do that? Well, it starts by deduction, right? So we got deduction. And now what do we do? Right? Here we have an or. How do you prove an or? Well, right? Here we have right? Let's see what, right? So how do we prove that's, oh, yeah, that's an and. How do you prove an and? What? Yeah, we're kind of separating it out backwards, right? We're saying if I want to prove an and, I have to prove each of them, right? So now I need to prove this and I need to prove that, right? Everybody see that? So now there are two things that I need. Now, how do I prove this one? Well, that's just deduction, right? So here's my deduction. I assume alpha and I need to prove gamma. All right? So how can I get, if I have alpha, what do I have? I have this line and I have alpha, and I need gamma. How am I going to get gamma from these? Modus ponens, to get modus ponens, yeah. So I'm going to do it by need, right? I have this, and I have this, and I want this, right? So let me just write down what I need, right? I need the OR, right? People see that? I mean, I don't know how I'm going to get the OR yet, but if I see here that if I can get the OR, then I'm done, right? And it's simpler. So I write down I need the OR, right? And now how am I going to get the OR? Well, I know alpha, so I know the OR, right? Does that make sense? Everybody good with that? And then we have to do the other one, right? So here I just say the other one was similar to the first one. Right? Everybody good? Oh, and then we get into there was that harder one which we don't need to cover now.